Hello boys and girls, this is Mr. So. Welcome back for another lesson of biology. Today we are going through lesson 19 about the pedigrees part 2 and also the classwork 26.3. Before you start watching the video, remember to like and subscribe my channel and also share the video to your classmates. Let's start. Let's take a look at question 1. Mediterranean anemia 地中海貧血 is a human hereditary disease by Bang. A pair of alleles control the disease. The pedigree below shows the inheritance of this disease in a family. How can we use the pedigree below to determine whether this allele for Mediterranean anemia is dominant or recessive? We have to choose the correct family first. Give you 5 seconds. Choose. Alright, I think you get the answer. The criteria for choosing a family should be, we should look for the family with the same phenotype parent, while the same phenotype parent giving birth to a different phenotype child, such as the case for parent 1 and 2, they are having same phenotype, giving birth to a different phenotype child 7. Or another possible choice is you can choose the family in green, having the parents 3 and 4 with the same phenotype and character, while they give birth to a different phenotype child 10. Let's take a look at question 1. Which phenotype, that means the character, normal or Mediterranean anemia, is the recessive character? Explain without the use of a genetic diagram. Alright, so choose the correct family. You can either choose the family in yellow or you can choose the family in green. This time I'm going to use the family in green. So let's take a look at the parent first. For the parents, 3 and 4, they are both normal parents. So let's write it down. Parent 3 and 4 are both normal. So therefore, they must have at least one allele for normal. Makes sense? So you get the first mark. And then, after looking at the parents 3 and 4, we can take a look at the offspring who looks totally different in phenotype than the parents. That is the offspring number 10. And then for individual 10, he has or is Mediterranean anemia. Okay. Therefore, he must have at least one allele for this Mediterranean anemia. He must have at least one allele of Mediterranean anemia. And this allele, it must come from the parents, which comes from or from either parents. So you get the second mark. It's from either the parents. And then what should you tell? For the third mark, you have to tell me, so that means for the parents, you don't know 3 or 4, they have a normal allele, and they might also have an allele for the anemia. That means at least one of the parents, at least one of the parent is heterozygote. You get the third mark. And then you can tell me in a heterozygous condition, which allele expressed, which one is masked? In heterozygote condition, dominant allele express while recessive allele is masked. It's not shown. So you get the fourth mark. So now the character showing must be the dominant allele. So this time the normal character is showing, so it's the dominant allele, and the recessive allele should be, the recessive character should be the Mediterranean anemia. So for the very, very last mark, therefore, Mediterranean anemia is the recessive character or phenotype. Alright, so you get the very last mark. So here are the keywords. For each of the answer, you must tell me the word at least one. So at least one for the first mark, and also at least one for the second mark. And then let's take a look at question B. State the genotype of individual 4. This one. And then define the symbol that you use. First, define the symbol. From the last question, we know that the Mediterranean anemia is the recessive character and the allele. So therefore, to begin with, let, for example, big letter A be the allele for normal blood. Or you just say normal. And then let small a be the allele for Mediterranean anemia. And then let's take a look at the genotype of individual 4. In order to know that, we have to first take a look at the phenotype of it. The phenotype of it is normal. So these individual 4, it must have at least one allele for normal, right? What is the other allele inside individual 4? To answer that, you must also take a look at the offspring. For offspring number 10 in here, he is a Mediterranean anemia patient. Therefore, for number 10, he must be having the allele of small a, both recessive allele to show the anemia. And now think, the two small a allele of individual 10, it must come from one from 3, and then the other one comes from 4. Therefore, for the remaining allele of individual 4, it must be a small letter a recessive Mediterranean anemia allele. To conclude, the genotype of individual 4 will be there will be big letter A and small letter a. And we call these heterozygotes. The very last question, can you suggest two sources of genetic variation as a result of heredity? You can give me any one, such as you can think of mutation, maybe 突變. This is one reason. Okay. What else? You can think about the process in meiosis. Some of the process in meiosis also give rise to genetic variation, such as number 2, you can talk about the independent assortment. Of chromosome in meiosis. Another possible answer is there is crossing over in meiosis as well. So you can tell me the crossing over of the non-sister chromatid of homologous chromosome. In the meiosis. You can give me the last one, such as you have so many variations because there is random combination of gametes during fertilization. And that's it. You can choose any two to answer the source of genetic variation. That's it about the pedigree part 2 and also the classwork 26.3. I hope you enjoyed the video. I will see you in the next lesson. Bye bye.